As we have a clear picture of what a dimension is and what a fact is, let's see what are the different types of schemas available within the dimensional model. All right, there are three types, which is star schema, snowflake schema, galaxy schema, which is also otherwise called as fact constellations. Right now, there are some articles on the web where it says that the galaxy schema and the fact constellations are different, but looking at it logically, both are the same. All right. So let's start with star schema. Now the star schema setup or the architecture in the dimensional model is the simplest of all the existing data warehouse schemas, right? It is called a star schema because the look of the setup, look of the diagram resembles a star, right? With points radiating from a center, which is a fact table surrounded by the dimensions, right? So usually the fact tables in star schema are in the third normal form, whereas dimension tables are denormalized. Now, despite the fact that the star schema is the simplest architecture, it is the most commonly used schema in majority of the data warehouse projects, and it is highly recommended by companies like Oracle, and also it is one of the recommendations from Kimball himself to keep it simple, right? Of course, if it meets your business requirements, but if it does not, you have to go ahead with your snowflake schema or anything else further which can be more complex, right? So what are the main characteristics of star schema? As you can see here, it has a simple structure, easy to read, centrally located fact table. We know what is a fact table, right? Now, from our previous sessions, we have already learned that fact table typically has two columns, which is the foreign key from the dimension and the measure values, right? Whereas a dimension, these attributes will hold the descriptive values which will support the fact table. These are usually the descriptive or the textual values, and these dimension tables are generally small in size than the fact table, right? So this structure with single connectivity of a fact to multiple dimensions with a foreign key is the simple architecture which is easy to understand, right? Great query effectiveness because you have limited number of tables, right? If you really have the star schema as it is, which is one fact and 5 dimensions, your joins will be less at the database level, right? So small number of tables lead to small number of joins, which will give you better effective queries, right? Which will also lead to the better processing time, right? Now, usually the relative long time of loading data into the dimension table, because it is denormalized, redundant data, could make the size of the table pretty large, right? Now, based on the data which the dimensions are holding, your query process also will be longer, right? This is one of the most commonly used in majority of the data warehouse implementations and widely supported by large number of business intelligence tools which are there in the market. All right. Now, if you have to take a look at the example, the one which we have been looking at from the beginning, which is the sales fact surrounded by product dimension, location dimension, organization dimension, and time dimension, right? Assume our data warehouse stores sales data and the different dimensions as we just spoke. Now, in this case, this figure represents our star schema, right? The lines between two tables indicate that there is a primary key and the foreign key, right? See here, the product dimension identifier is a primary key, and when it comes here, it becomes the foreign key. Similarly, it's the same for rest of the dimensions, right? Note that the different dimensions are not related to one another. Those are individual, and those make sense when you look at it individually, but you cannot connect these two together, right? when they are read with a single measure value, those make sense. All right, so that is the star schema. I'll repeat it. A centrally located fact table surrounded by individual dimensions which resemble a star is the star schema. All right. Let's look at the snowflake schema now. Now, the snowflake schema is an extension to the star schema, right? Where each point of the star explodes into more points. In a star schema, each dimension is represented by a single dimension table, right? Whereas in a snowflake schema, that dimension table is normalized into multiple lookup tables, each representing a level in the dimensional hierarchy. Look at the time dimension here. Now this time dimension, which is having the date as the primary key, is leading into month, right, which is also rolling up to a quarter, right? Take another example here. You have shop, which is leading into city in which the shop exists and the region in which the city exists, right? If you look at product here, it expands into three sets. One is the product type, the other is the brand of the product, the other is the supplier of the product, right? So these lookups, so we will have 4 lookup tables in a snowflake schema in this example which we have taken. So the main advantage of snowflake schema is the improvement in query performance due to minimized disk storage requirements and joining smaller lookup tables. So in star schema, what has happened is, as you do not have multiple splits, you are keeping all the data into a single dimension, right, which could increase the number of columns and the number of rows as well, based on the data which you're populating. However, as you're splitting it here, you will do the join only when you require the data from there. For example, if you want to get the region for a particular sale, how often do you need it? Usually if it is from the shop, you would know what region that shop is from. Now, until unless you have to report it to some third party saying, or you have to get a half yearly analysis or an annual analysis on the region based profits and loss, then you would go for the region, right? Or even if it is a regular structure, you have to have this join between 3 sub entities or 3 dimensions. How do you join that? So from sales, you select ID shop, which has ID city as the primary key, which is connected to the city dimension, and which has ID region as one of the other primary keys, which will connect to the region. Now this can still expand from region. It can go to state, it can go to country, it can go to the continental areas like APAC, Europe, America, etc. Right? And though it is an advantage, there is also a disadvantage that you have to maintain more number of tables, right? And the additional maintenance efforts needed due to the increased number of lookup tables within your schema, right? So that's about the snowflake schema. We'll look at the differences in a while. Now, what about galaxy or fact constellation schema? Now, a fact constellation has multiple fact tables, right? It is also known as galaxy schema. Now, in this diagram, you can see 2 different facts, right? Like sales and delivery. Now, the sales fact table is the same as it is in the star schema. There is no difference. Now, the delivery fact table has 4 different dimensions connected to it, right? Namely supplier, time, product, and not directly but indirectly connected to country, brand, and supplier, right? Now, the sales fact, which is the second in the schema, also contain product and time, along with other dimensions like shop, client, with multiple dimensions, right? So it is also possible to share dimensions between fact tables. For example, time and product dimensions. Here time is connected to delivery and it is also connected to sales. Product dimension is also connected to delivery, and it is also connected to sales, right? That's the fact constellation schema. Now, whenever you use the same dimensions for two different facts, it is also called as a confirmed dimension. We'll talk about that separately in another lecture. All right, so quick recap. There are three different types of schemas. One is star schema, snowflake schema, galaxy schema, or fact constellations. What is star schema? Star schema is the simplest of all. It has a centrally located fact table surrounded by related dimensions. Snowflake schema is an extension to star schema with more detailed dimensional data. You can also call them as hierarchies. Galaxy schema or fact constellation schemas are the ones which has multiple fact tables and which also leverages the commonality of dimensions and try to reuse them between facts, right? So those are the different types of schemas within the dimensional model. Now let's look at the main differences between the star schema and the snowflake schema. Now this is one of the common questions which comes up in most of the interviews if you're looking for a ETL developer, tester, or administration, or anything which is related to the data warehouse and business intelligence concepts, including your OLAP developers or BI developers, right? Let's look at each of the concept. Now everything is what we've seen, but let's do a quick review so that we cover all the points. All right, ease of maintenance or change. Now as star schema is in the normalized format, is in the third normal form, it has redundant data, right? So it is little less easy to maintain or change the data in case if you need it. Snowflake schema does not have any redundant data or duplicates, so it is easier to maintain and change because everything is driven by a primary key or a business key, which is easy to identify for any of your inserts, updates, or deletes. Ease of use, lower query complexity and easy to understand because you have less number of entities within the star schema, right? Snowflake schema, more complex queries and hence less easy to understand because you have hierarchies to the dimensions. Now if you have to get the supplier detail, you have to connect it with brand and then connect it with product. If you have to get the value of it, obviously you need to link it to the fact table, right? Query performance, obviously faster because less number of foreign keys because it always looks like a star, which is 4 or 5 at the max for a star schema. More foreign keys because you have larger number of dimensions, larger number of hierarchies within that. Types of data warehouse, good for data mart with simple relations like one-to-one or one-to-many, but this is good for data warehouse implementations because it has many-to-many relationship. Joins, obviously fewer. This is higher number of joins because of the dimension numbers which you have in star and the snowflake schemas. Dimension table, star schema contains only single dimension table for each dimension. Snowflake can have beyond one because of the hierarchies or extensions which are more detailed in nature. When to use, when dimension tables contain less number of rows, you can choose star schema. When dimension tables are relatively big and can be expanded into more detailed aspects, then you'd go with snowflake. Normalization and denormalization. Both dimension and fact tables are denormalized in form, which is they will contain the duplicate data. However, on the snowflake schema, dimension tables are in normalized form, but fact table is in denormalized form. Again, though we talk about this from the concept perspective, but end of the day, it is what the business needs and how they want to look at the data, right? It is all driven by your requirement. There might be situations where you have to keep the duplicates at both levels, though if you're going with snowflake schema, and there are cases where you might have to do the same or you might have to keep it unique without any duplicates if you're going with star schema as well, right? So it is the drive, business requirements are the drive, right? So you consider these concepts, but the business requirement takes the priority. Now, there could be situations where you might have to include it in combinations. From concept perspective, let's say you're using Snowflake schema in the data warehouse. You might have to keep it normalized, but if there is a requirement they also need it in denormalized form, you might have to create another entity, other fact or another dimension where you have to keep it in denormalized form. All right. So the whole point is concept has to be followed, but your business requirements take the priority. All right. Data model, top-down approach. In Snowflake schema, it is a bottom-up approach. Right, these are the core differences of star schema and the Snowflake schema. Now, in any practical situation, you always go with a Snowflake schema because all the businesses nowadays are so complex in nature, or the moment somebody thinks of data warehouse, they want everything to be there in the data warehouse, isn't it? Right, so you might end up creating 5 to 6 different fact tables which are related to your business and all the related dimensions which will support that fact table. Right, so it might go to a level where you have 5 to 6 fact tables and about, let's say, 80 to 100 dimension tables which are directly or indirectly connected to your fact tables. All right, those are the differences between star schema and the Snowflake schema.